point X will lie on this line, yes or no? Right? So it's either it will intersect the bottom where the shear stress is, or at the top. If you look at point X over here, that 30 over there acting at point X surface, the element will rotate clockwise or anti-clockwise. Anti-clockwise, yes or no? You look at this 30 over here, right? This line over here will rotate why? Anti-clockwise. So anti-clockwise is top or bottom? Bottom. Okay. Then the one at the top. Now we look at the Y line. Okay, so this is the Y line. The element is going to rotate in which direction? Based on this one. Clockwise, right? So clockwise, this will be at the top. So this is your Y. So from here, you can construct a straight line. And likewise, you can do very straightforward calculation. So the first thing that you calculate is known as center of circle. So center of circle is also known as your what? Stress average. So stress average is equal to stress X plus by stress Y. Average, yes or no? So it's plus, okay? So this is equal to 60 plus by minus 80 divided by 2. Remember, stresses are vector dependent. Don't forget about the what? The sign. So this will be equal to minus 10 megapascal. So when you construct, it's at your 10 line. So I'm going to use green. So this point, immediately label as your point O. Okay, at your point O. Next thing that we can calculate almost immediately is the radius of circle. And the radius of the circle is known as your what? Tau max. Okay. So tau max is equal to your shearing stress. Your shearing stress is equal to 30 squared plus the distance from here to here. So where did we get the 30 from? Okay. The 30 we got is the distance from here to here. Hey, come on, Eugene, seriously? The 30 that we draw, that we get is the distance from where? From here to here. This is your 30. And then the other line that we need to know, or the other length that we need to know, is the distance from your stress Y to the where? Stress average. Okay, so this is 20, 40, 50, 20, 40, 60, this is equal to 70. Not to the center, not to the zero as in the original, to the center of the circle, right? So 20, 40, 60, 70. So it's 70 squared. Nothing to memorize. It's high school, not even high school. Okay, so 30 squared plus by 70 squared, square root of the whole thing is 76.157. 76.157 megapascal. Right? So what we have calculated is this distance over here. Let me use a different color to elaborate. What we have calculated is the distance from here to here And over here, this is our radius. We clear? Okay. So from here, you can calculate your stress 1 and your stress 2. So this is equal to minus 10 plus or minus 76.157. So at one spectrum, this is at minus 86.157. At the other spectrum will be positive 66.157. So from here, we know that where is our stress 1 approximately. So this is my stress 1 point, and my stress 2 point is somewhere around here, approximately. Yeah, approximately. Okay, so now I will draw my mole circle. Oh, this is real stupid. The software is like, oh no, it can be the user. Yeah, this is as good as I can get. Yeah. Straightforward. That is your mole circle. Okay, so you have calculated the principal stresses, we have calculated the tau max, and we have calculated the average. Okay. So next, we are going to calculate the orientation of the principal stresses. So we know, okay, we know that this is our stress 2, whatever, okay? This is your what? Stress 1, okay? So what we want to calculate over here is we're going to calculate this orientation, and this is known as 2 theta P. Okay. P is the orientation of your principal plane. And this orientation is very critical for the orientation of your carbon fiber reinforced plastic, how your fiber should be aligned. Okay. Now, if we come back and look at carbon fiber, if you orientate your carbon fiber in this direction, what happens? When you see a shear stress, oh yeah, it will see shear stress. And carbon fiber, they hit what? Stress. So we have to find this angle over here, the 2 theta P. We have to find this angle because we need to know at what orientation this is equal to what? 0 what? Shearing stress. Carbon fiber love what? 0 what? Shearing stress. There you go. Okay. So from here, to find tangent to theta P, is equal to 30 divided by 70. Okay, so this will be equal to 30 divided by 70. Inverse tangent is equal to 23.198 degrees. So 23.2 degrees. This is your 2 theta P. Okay, and then theta P is equal to 23.2 divided by 2. Okay, so 23.2 divided by 2. 23.2 divided by 2 is equal to 11.6 degrees. 11.6 degrees anti-clockwise, because from point X to theta P is what orientation? Is anti-clockwise orientation. Now, some of you say, Eugene, can you do from point Y? Yeah, answer will be the same. Yes, you can. Yes. Everything is the H, but it's orienting at where shear stress is equal to 0. Okay. So now you see over here, if you use from point Y, the rotation is also the what? The same. Yes or no? Both rotate in a anti-clockwise direction. So, what does this actually mean? So now I'm going to teach you from mole circle. Now, mole circle is like your calculator. It's like the number that you see. What do you do with the number in real life is a different thing. Yes or no? So now we are going to bring it back to the what? To the real world. So how do we bring it back to the real world? Now we have to construct from mole circle, go back to the what? Element. Okay. How do we do that? So now we draw the axis. Okay. So this is our original x-axis. And then we have our original y-axis. Okay. Now what we are going to do is now we are going to bring it to the what? We're going back to the element. Okay. So now, in the real world, we will rotate by how many degrees? 11.6 degrees anti-clockwise from the horizontal axis or from the what? Vertical axis. Okay. And you all understand why we only rotate by what? Theta p now. Yes or no? In mole circle is 2 theta p. In real world is what? Theta p. Okay. So now we're going to rotate it anti-clockwise by 11.6 degrees. Oh, poor fishy, don't run away. So anti-clockwise, 11.6 degrees. Huh? Yeah, I'm still old school, man. And I put the tape down here so it will not, So 11.6 degree. Sorry, I'm still like very old school, okay? So 11.6 degree. Yep. 11.6. So only can draw 11. Okay. So now this has been rotated by 11.6 degree. Okay. So I do this, copy, paste, rotate by 90 degrees. Here we go. Okay. Okay, so now we have this. So now I'm going to draw the box, the red box. Tilted at 11.6 degree. So I'm going to use green to tell me on this surface over here, the vertical surface, this is in fact my X. My horizontal, this is actually my Y. Okay. Now I finish copying. I want you to stop and I want you to listen to me, because now we are going from the what? From the mole circle back to the what? Back to the element. Okay, watch it. Point X is point X over here. Yes or no? And then it rotate by 2 theta p. You get how many? What's the magnitude? 66.157. Right? In what direction? Anti-clockwise direction. So X rotate anti-clockwise direction. You touch this line. Yes or no? By theta p. So that over there, that angle over there that you see is tensile And this angle or this stress is 66.157. Okay. Now let's look at the Y. Right? The Y on the mole circle, the Y on the element. Rotate by 23.2 degrees anti-clockwise. From Y, rotate by 11.6. Stress magnitude is 86.157. Simple? No, not difficult. So now, what do we learn? We learn element to where? The mole circle. Then after that, from mole circle, bring it back to where? The element. Okay. Why we have to bring it back to element? Because this is where real life is. Mole circle is just a what? An analysis tool. No point knowing how to analyze, only know how to analyze and don't know how to apply. Absolute waste of time, waste of money. So now, what does it mean? I.e., if I were to now look at this structure, and what I will do is I'm going to lay my carbon fiber now. Okay, I'm going to lay my carbon fiber now. My first laying direction that I'm going to use is this direction. Hey. Okay, we are going to lay it in this direction. Okay, so the first lay direction relative to the object is 11.6 degrees. At this plane, the shear stress is equal to what? So, strength of the carbon fiber of plastic and you look at the software. You need what is smart in between your 2 years, are we clear?
That's just visually able to do parts, right? Like this.
Okay. Are we clear? Okay, now I will do a demonstration. What if we screw up the what? What if we screw up the shear stress? Let's say you know nothing about shear stress. Like me when I was young. You know nothing about shear stress. So I'm going to copy the page. And I'm going to paste. Don't worry, everything. So I'm going to call page 8 error. Okay. So what if now you screw up in the orientation? Right? So this is not your correct orientation you're going to use. But you label wrongly, this is your point X and this is your what? Point Y. This is wrong, by the way. Yes or no? So when you use the wrong one, now you draw a straight line. Right, now you draw your straight line. Then you realize now, because this is wrong, okay, this is wrong. Now, because of the wrong, you realize that you are going to orientate this by 2 theta p. And theta p is equal to what? 11.6 what? Degrees. Wrong. Then if that's the case, you are now going to orientate your carbon fiber now, not in this direction, yes or no? You are going to rotate in this direction now. Okay, you are going to rotate 11.6 degrees based on this angle now. So what happened? Wrong. I told you what. Art student can also do get the wrong thing. Are we clear? Especially for carbon fiber, this is really critical. If you were to design materials made of steel, materials made of aluminum, does not matter. Why steel and aluminum? Why does it does not matter? Anyone? Because the material is isotropic, homogeneous in every one direction. Carbon fiber is not. That's why the software to design this is so expensive. Very clear. Then this you have to be precise. You get it wrong, it's a complete waste of time, it's completely waste of money. And welcome to Jamaica. I'll see you guys next week. So you guys are right. Go. Okay, go.
I don't think they have.